Welcome. In order to accommodate latecomers and also the complexity of today's presentation, we've recorded the material so that you can play it back and fast forward at your own pace. In the meantime, feel free to address any questions via the chat window in the WebEx client. And now, let's begin with the presentation.
Welcome to the Apps, Security and Compliance webinar. This presentation is divided into two parts. The first part will focus on data security, where you'll understand the design principles and the fundamentals of our architecture, particularly with respect to protecting data in transit, as well as data at rest. In the second part, we'll take a look at some concrete examples of how we use these technologies in our products. Given that the definition of cloud computing implies that your applications and data are hosted on shared infrastructure, it's important for you to feel comfortable and to understand the infrastructure that's being used to deliver and protect that information. With that in mind, consider that from its very inception, Google has always been a cloud-oriented company. It's by no means a change in direction of our organization, nor is it an approach that's new to us. In fact, if you take a moment to consider the major milestones that we've accomplished along the way, I think you'll agree with me that every new stage of development takes advantage of work that was done in the past. For example, in the beginning, we built massive data centers to host an index of the entire web. When we exceeded the capacity of traditional software, we ended up building our own. That activity generated so much mail that our engineers created a tool to help manage very large volumes of email. We released that as a community service in 2004, and in 2007 we extended that service to include other utilities such as word processing, spreadsheets, presentations, etc., calendar. So, because of that simple historical fact, security is a pervasive concept throughout our entire organization, starting from our information security team, made up of individuals with very impressive accomplishments in both academic and corporate computing. They're responsible for a range of activities, including developing custom processes to ensure the automatic patching and identification of potential vulnerabilities. They also help with some of the more administrative tasks, which allow us to interact with auditors and to communicate the controls that we have in place. For example, for auditing standards such as SSAE 16 or PCI, FISMA, etc. This is supported in large part by the technology which we have built from the bottom up specifically for this application. One example of what that technology and our ownership of that enables us to do is to deliver features such as two-factor authentication at no additional charge to all of our users, whether they be business users or consumer users. Currently, well over 3 million businesses are being protected by this technology today. We continue to embrace and extend the auditing standards that we support to the extent that our customers find them useful. For example, the FISMA specification, which is part of a federal government standard that's widely used here in the US, is built on a more familiar foundation of ISO 27001. In the event that we were to embrace ISO 27001, assuming that it becomes more popular than it is today, it's conceivable that we might go ahead and extend our certification to include that. I'd like to talk for the next few minutes about some adjacent design principles that are related in some respects to security. One of them is transparency. Transparency is the ability to communicate to customers the details of the behavior and the status of your applications. If you go to www.google.com/transparency report, you'll see a number of very interesting summaries and reports available to the general public, including, for example, summaries of and analyses of content removal requests by country or by product, as well as user data requests. You'll also see a traffic report, which might be particularly interesting for those of you who might have operations overseas. In the traffic report, you'll get a sense of the volume and availability of traffic by application as well as by country. And in the event that there are some potentially severe incidents impacting access to our services, there's likely to be an incident report link at the bottom of the page. Another adjacent design principle is the notion of reversibility, which is really no more complicated than the idea that because your data belongs to you, we should design our products in such a way that it be no more difficult for you to extract your data than it was for you to enter it in the first place. There's a playfully named site called dataliberation.org, which goes into more detail on a product-by-product basis of which public specifications for protocols and file formats we support in order to facilitate your easy access to data on demand. Now I'd like to spend a few moments talking about protecting data in transit, particularly because there are certain instances where you might not yet be in a position to have Google host your applications and your information, but you would still like to take advantage of our massive infrastructure investment to protect your local networks. Perhaps the best example of this would be the area of mail security. Several years ago, the industry settled on the notion of using an upstream provider to deliver mail security so that your local resources would not be negatively impacted by unpredictable bursts of traffic that you didn't expect nor ask for in the first place. One very well-known example was a company called Postini. Postini was acquired by Google in 2007, in part because of some of the very innovative technology that it used internally. While it's certainly true that there are many vendors who have a similar presentation in terms of hosting their services in the cloud, those of you who might have used Postini in the past, or perhaps have had acquaintances who have used Postini, might have at some point wondered why it was that Postini users experienced different, incidentally better, results than those using other types of mail security technologies. It turns out that that experience has a very simple technical foundation. First of all, SMTP is typically handled using a technique called store and forward. When the Postini engineers initially designed the service, they realized that there were a number of vulnerabilities in that model that would prevent them from potentially supporting 100% of all internet mail traffic. As a result, they designed an application that looked very much like an SMTP server to the outside world. However, internally, it behaves quite differently. So, rather than sequentially passing traffic from one service to another, and then eventually making its way out the other end over to your mail gateway, the Postini proxy accepts the initial connection requests, assuming the connection looks good, and we'll discuss that particular point in the next slide. Assuming the connection looks good, the initial SMTP transactions are received at the Postini proxy and then concurrently passed over to your mail gateway through an SMTP session which is maintained in parallel rather than in series. So as your server acknowledges the SMTP connection requests and the subsequent SMTP commands, Postini passes that information to the sender, and the sender proceeds with the rest of the session. That forces the proxy to run all of its applications in parallel rather than in series. It also enables us to continue to add new applications without introducing additional performance penalties or failure points. Given the failsafes baked into SMTP, this also allows us to ensure that messages are never lost. Because if at any point in the session the connection were to fail, say to your mail gateway, or perhaps there might be a failure inside our environment, the sender would not receive the corresponding SMTP acknowledgments. As a result, they would simply retransmit, which is consistent with the SMTP behavior that's been in place for the last 20 some odd years. Now, interestingly, this also led to a number of coincidental benefits. For example, the fact that a message is not being sequentially passed from one mail queue to another makes this environment very, very easy to troubleshoot. Messages are not in some mysterious intermediate state. They're either in the sender's queue, the receiver's queue, or potentially in our quarantine database, which incidentally you have real-time visibility into. Another incidental benefit was the lack of persistence in this environment. In other words, the fact that good messages need not be written to disk made this extraordinarily popular among the legal and financial services industries. And finally, the ability to associate policies, configuration options, and access controls to individual users within the same domain made it very easy for large, distributed, multinational organizations to carve up their user base into various sub-organizations and determine which members of their staff would have the ability to support particular groups of users. So that delegated administration facilitates the distribution of responsibilities within an IT organization. So earlier I made the comment that we would determine whether a connection looked good. That comment came from a discovery that we made in 2002 when we began to compare the traffic statistics from one proxy to another. Because these proxies are run in massively parallel arrays, at any given time we'll have hundreds of thousands of SMTP sessions open simultaneously. And we discovered that the behavior of a server is a very important and very accurate indicator as to the quality of the data it's carrying. Another way of looking at that is that bad servers behave differently from good servers, if for no other reason, because they often are not mail servers to begin with. Typically, they'll be parts of a botnet, zombie PCs sitting at the end of a DSL link. So our ability to look at the behavior of a server made us much less dependent on decisions and analysis of the contents of the message payload. It turns out that while spammers and phishers have a great deal of control over the message payload, there are only a number of ways in which they can move large volumes of data through the internet. We're fortunate that this technique allows us to dramatically lower our false positive rate. And, incidentally, its effectiveness increases as a function of the volume of mail that we handle. So as we handle more and more mail, and as we route more and more traffic from disparate locations to disparate locations, this cross-sectional view of traffic patterns becomes faster, more responsive, and more accurate. Incidentally, the delegation of administrative privilege is made possible by a policy database. That policy database includes a series of access controls which determine the degree to which an administrator might make changes to a particular user's profile. So when you combine an extraordinarily high-performance mail processing engine with an access control database and include an extremely cost-effective custom-built storage environment specifically designed to deal with very large volumes of mail, you end up with an early ancestor of what today is called Google Message Discovery. Once again, an example of how the work that we do today is a logical extension of previous accomplishments. Now let's take a moment to talk about protecting data at rest. Data at rest is particularly relevant to those of you who might be storing your mail, your calendar, your documents inside our servers. And before I get into the details of how we approach this problem, I'd like to simply review the model, the framework that all of us have in our minds when we consider or when we envision a cloud solution. This model hasn't changed very much in the last 30 or 40 years. In fact, there's very little room for improvement left in this framework. Potentially, one can achieve certain economies by moving from a dedicated to a shared environment. A shared environment being one where multiple servers might be made available to a group of customers. However, the fundamental limitations, the reasons why many of you have engaged this webinar in the first place, those limitations are fundamentally the same. So, for example, the more people there are in this building, the slower things tend to be. The longer this network connection, the slower it tends to be, and of course, if this connection were to fail, then you need to have an alternate. Back here at the data center, you're hoping that no activities, either by your neighbors or by the maintenance staff, impact your particular operations. And most importantly, and this is probably the reason many of you have attended, there's a very fundamental problem with this model, and that is that the hardware and the software running inside that data center were originally designed with the assumption that the person building the box also had the authority to access its contents. So from that basic assumption, any security measure is bolted on as an afterthought. Now, it's very unusual that any organization have the opportunity to fundamentally revisit that paradigm. As it turns out, we were fortunate enough to have access to the resources that allow us to build our own servers. In fact, anecdotally, analysts claim that if Google were to sell its equipment on the open market, we would be roughly the world's fourth largest server manufacturer. Having said that, the servers that we built are specifically designed and constructed for our environment. They boot with a very minimal custom Linux operating kernel. And on top of that, we load our own internal proprietary tools and resources. In the case of Google Apps, the storage replication happens in real time, and we duplex the traffic to two disparate data centers. In each data center, there end up being 3 copies of every piece of information. So this is an environment that was purpose-built for cloud computing. In our material, you'll often hear the term purpose-built, referring specifically to the fact that we didn't simply redesign equipment that was manufactured for a different application. I've made an attempt to consolidate much of the material around how we index and store data to a relatively simple diagram. The point that I'd like to make here is that all of the customer's data passes through the same fragmentation and reassembly process. So if you will, the cloud refers to an indexing system that we've designed which fragments the incoming data streams into small chunks with random labels associated. That information is then handed over to a storage environment. The storage environment consists of very, very many drives. And more importantly, there's no consistent fixed relationship between any particular drive and the chunks of data which are stored on that particular medium. So as a result, we've effectively shredded our data across a vast array of hard drives. The administrative staff who manage the hardware are different from the administrative staff who manage the indexing systems. So, from a performance and reliability perspective, this has a very nice smoothing effect across all of the data that goes in or out of our facilities. And you don't need to take my word for it. Any of you who have had an opportunity to travel may have noticed that your experience with Google Apps, YouTube, Gmail, Google Calendar, Picasa is similar, whether you're in Seattle or London or Tokyo. So, I'd like to talk a little bit about some of the additional features that are specific to Google Apps. For example, if you have ActiveSync enabled smartphones, such as iPhones, Windows Mobile, Android devices, you'll be pleased to know that we support the ActiveSync policies natively in the Google Apps control panel. So you'll be able to access familiar operations such as enforcing password policies on the handsets, encrypting data on the handsets, doing remote wipes, assuming of course that the handsets support these features. You also have a number of authentication options. So for example, if you use Google accounts, in other words, if you use the authentication servers which we host for free, you can certainly use usernames and passwords. However, we encourage you to consider stronger authentication, specifically two-factor authentication, which is included as an option for all Google Apps customers. You can also use your own authentication servers. The protocol called SAML, which stands for Secure Assertion Markup Language, is the foundation of what's typically known as federated identity. This allows you to specify a particular authentication server of yours so that whenever one of your users tries to access a Google server, Google redirects that authentication request to one of your resources, which then approves or denies the access request. Assuming the access request is approved, you then pass on a credential which that user session can use to proceed with their Google Apps transactions. Many refer to this architecture as single sign-on, which is in fact one of the features of this technology. You can also authenticate individual messages using the common standard called domain keys. DKIM is used widely through the email administration community, and if you happen to be a DKIM user, you'll be pleased to know that you can continue to use that approach with Google Apps and even conserve your existing domain keys if that's your choice. You can even authenticate individual applications. So if you had to run a script or utility at a specific level of privilege, you could use OAuth, which is a very common authentication protocol enabling various web applications to authenticate with each other. We continue to expand and enhance the activity reports and the usage logs. I would encourage you to take a moment to look at the options in the Advanced Tools section of the Google Apps Control Panel. Incidentally, the information that is stored in the internal database exceeds that which is exposed in the basic off-the-shelf reports. So you'll be pleased to know that there are, in fact, additional opportunities for accessing even more information than you get by default. Now let's take a look at the second part of this presentation, where we focus on specific examples in particular products. There are instances where you might need to get a particular message sent securely to some random internet destination. In that scenario, you can take advantage of Google Message Encryption. Google Message Encryption is the extension of the policy framework, which evaluates messages as they leave your environment, and in the event that the destination has no registered certificate in our global directory, the message is then redirected to an online portal where the recipient can then connect and retrieve it over an HTTPS, that is to say an SSL, web session. On the return, as those messages reach our filtering environment, they're correspondingly decrypted and handed back to you, or handed over to your users in the clear. So as a result, your end users need not change their behavior in any way. And perhaps more importantly, in the case of the online portal, the notifications are very simple and the registration process is very familiar based on the typical practices associated with registering for an online commerce site or an online banking session. You can, of course, customize the contents of the interface and determine what options are available to those members of the public that are using this to communicate with you. And in many cases, our customers will choose to add their own artwork and their own colors and branding elements to make the portal appear more like part of their online property. On the back end, administrators can enable a wide range of filters and policies to determine when a particular message should be encrypted. Google Vault allows you to take advantage of the sophistication of our back-end technology in conjunction with our easy-to-use and reliable web interfaces. Using Google Vault, you can very easily store your information for very long periods of time and even have numerous policies that determine how long particular types of information should be retained depending on criteria that you select. In fact, you can also use criteria of different categories to later on go to retrieve and identify relevant pieces of information and in fact export those if necessary into files which you can then deliver to other business partners or other stakeholders. There is in fact an industry model for records preservation which might help illustrate where Google Vault fits with respect to how records are retained and processed. This model, which is generally referred to as the EDRM model, essentially contrasts volume versus relevance. So typically, where volume is very high, there are often very few items which are relevant, and the technology that you typically use to manage very high volume data is often different from the technology that you use to manipulate and analyze and present small numbers of highly relevant pieces of information. So another way of thinking about that is that Google, with Vault, helps you manage the high volume of information so that you can identify pieces which might be relevant and then collect and preserve them. So let's take a look at Google Vault in action. To the Google Apps Vault screen, you'll notice that there are effectively two silos. That's how we tend to think of these. There's a category for retention, and that deals with the policies around how long a particular type of data should be stored. So you can specify characteristics of data, and then also the period of time which that data should typically be retained for. By default, in this case, the period is 100 years. Now, the other silo refers to e-discovery, which is effectively the retrieval, the processing, collection, etc., of data which either belongs to you, or which might be shared with you, or which in some cases might pertain to an investigation. We use the term matter to refer to that, and you can think of it as a folder which collects different sets of queries and export files, etc. If I were to open a particular matter, notice that I get an additional tab up here at the top, so I can always go back to my home screen by clicking on this My Matters tab. And down inside the contents of this matter, I can see the various users whose information is being held. Within that group of users, I can perform searches, different types of queries with different types of criteria. Clicking on these saved queries, I can effectively replay those searches and examine them online. So let's take a look at these results. Notice, for example, that the text version of this query here illustrates the various terms and conditions that are being used in the filter. And in fact, the results will contain both conventional emails and instant message chats. It's quite likely that I'll want to export this information. So when I go to my Exports tab, I can see any previously exported files, as well as any exports which I might have in progress. And finally, I can also review the activity that investigators have performed by selecting a date range and choosing the types of events which I would like to report upon. And in fact, if I needed to constrain that to a particular set of users, I could add that as well. I can choose to download a comma-separated values file containing the audit report. In this case, I can open and browse the comma-separated values file with any spreadsheet software.
Welcome. In order to accommodate latecomers and also the complexity of today's presentation, we've recorded the material so that you can play it back and fast forward at your own pace. In the meantime, feel free to address any questions via the chat window in the WebEx client. And now, let's begin with the presentation.